So for example, if we were to take that word problem we just did where we did 2,000 joules of work, 2,000 joules of work, we just did this problem, right? Okay, but we had a distance of 1333.33 meters. So let's say we push this box 1333.33 meters. And we used a force of 1.5 newtons. Did that force ever change while we were pushing it? In the word problem, no. So the whole distance, the force is unchanging. This is a straight line. I can't draw a straight line to save my life. Okay, that's because I need to use the bar. There we go. Straight line. So the force is 1.5 newtons the whole time, and work equals force times distance. Well, if I multiplied my force times my distance, what did I just find? I just found the area of this figure. Length times width. Okay, I just found the area. So by finding the area of a force versus a distance graph, you are actually finding the work. Now, for this type of figure, does it really help us? No, we're just showing you that you can do that. The area of a graph is actually a very important math concept. It's as important as slope, okay? There's a whole thing called calculus where all you learn is how to take area of figures that aren't regular shapes. Now, where this really becomes helpful though is I have a machine. So when you turn on a motor of a car, for example, it doesn't start automatically right at 1.5 newtons. There's a little bit of time where it starts at 0 force and then the force gets bigger, okay, until it maxes out, okay? And then it might be a constant force. So I could actually take the area of this triangle and then the area of the rectangle. So the area of a triangle, 1/2 base times height, and then plus the area of this rectangle, okay, length times width. But in both cases, we've got force and we've got distance. So this would still be work, and this would still be work. Work plus work is the total work. And this all works because look at this equation. It says force times distance, force times distance, force times distance. So it's just finding the area. It's amazing because we're taking a lot of things you learn in math, and after a while you're like, why are we learning this? Well, when we actually apply the math, it tells us things we can actually use. Why is this important? Machines do work, okay? Any machine that you use, even simple machines like a screwdriver, a wheelbarrow, all those things actually change how we do work. And sometimes it's easier just to graph it and go, oh, well, there's the area. I can do that. That's easy. Okay. So yeah, that's the short version.